All right, so for 53, what we have is we want to calculate the acceleration due to gravity on the moon. We're going to use the equation G, the gravitational constant, capital G, times the mass of the moon all over the radius of the moon squared. Now, to find the radius of the moon, and we'll do a capital R sub m. Let me write this a little better. Let's use a different color too. The radius of the moon, well, the diameter of the moon is equal to 3,500 kilometers. We did that on one of our other homework problems. But what's the standard unit of measure for length in the metric system? Meters. So how many meters is that? That's a lot. So it's about right? 3.5 million meters. Because kilometer is, you just multiply it by 1,000. And when you multiply something by 1,000, you really just add 3 extra zeros on the end. Now, what's 1/2 of that? It's 1.75 million, or 1,750,000. That's the radius. Well, we could use scientific notation and say 1.75 times 10 to the 6th, right? Because if I move this 1, 2, 3, 4, 5, 6, I'll get a decimal point right here. Okay, see what I did? Okay. Phew. All right, so now that we have that, only thing I need now is the mass of the moon. Now, if you guys don't remember what the mass of the moon is, where could I find that? In the book. The last page of your book has all that stuff. It's under the solar, they call it solar system data. And so the mass of the moon is 7.4 times 10 to the 22nd kilograms. Now, kilograms is the unit for mass, so we don't have to convert anything there. Now, what is G? Well, G, capital G, the gravitational constant, is 6.67 times 10 to the 20, I can't remember off the top of my head. Oh, negative 11. Boy, that was embarrassing. Mr. Ed, I'm so tired. I'm so tired. I was thinking of moles is what I was thinking. They're similar. All right, so now I just need to plug all this stuff into this equation, and I'll get an answer, right? So we're going to say that the acceleration due to gravity is equal to 6.67, right, times 10 to the negative 11, and then the mass of the moon is 7.4 times 10 to the positive 22, and then the radius is 1.75 times 10 to the 6th, but we got to remember to square that whole thing. Is that right? Does that look right to you? Now, grab your calculators because we want to practice that. So get your calculators, turn them on. I want you to go through the same procedure with Mr. Adams. Okay. All right. So, oh, you can see I tried to do it earlier. So what I'm going to do is, well, let me move this. Well, let me move this a little bit out of the way. Oops. So I can see everything. All right. 6.67. Now, if you want to do the times 10 to the whatever, if you hit second comma, you get that little e. Remember, that means the same as times 10 to the whatever. So I'm going to put negative 11 here, and I'm just going to put the negative sign 11 times 7.4, and then I'm going to do this E thing again to the 22. Now before I hit enter, what's 7 times 6? 42. What's 7 times 7?
49.
49. So we're going to get anywhere from 4.2 to 4.9 times 10 to the something. Okay, does that make sense? Now, what is 22 take away 11? 11, right? So then we've got that 42 business going on. So even if we're really bad at math, we know that it should be 10 to the positive 12, 10 to the positive 11, somewhere in there. If I get something outside of that order of magnitude, then I probably made a mistake. Okay? So if I hit enter, 4.9 e to the 12. Pretty good, right? All right. So now I want to divide by this stuff here. Now I have to be careful. I'm going to say divide by, then make parentheses, 1.75 e to the 6. Then I got to square the whole thing. Now what's going to happen here with the 6 and the 2? What do I do with those numbers there? Multiply. So really when we talk about order of magnitude, I'm going to have 10 to the 12 on the bottom. What do I have on the top? 10 to the 12. So my order of magnitude will be plus or minus 1. Okay? Does that make sense? So let's see what's going on. It's 1.61. Okay? So what does all that stuff mean? Well, that means that my acceleration due to gravity is approximately 1.6 meters per second squared, which is about 1/6 of what the acceleration due to Earth's gravity is, which is 9.8.